Good morning, guys. Hopefully everybody's having a great day. Today I wanted to show you guys a final product here when it comes to access controls, um, enclosure, head end. Here we have what we call these boards right here are your Mercury boards, and this kit here, it's a 16 kit enclosure, meaning that you can add 16 card readers inside of this enclosure. This enclosure has all your required power supplies here on the side, for your locks, and if you're going to be adding motions or silences or any other device here, you land them here, and then your locks right here. We're going to go over that in a little bit right now, but just let's go ahead and go step by step. So first of all, this is your 16 kit life safety power supply enclosure. Each one of these boards right here takes two doors, two card readers, and you can go ahead and obviously actuate two locks, and I will show you guys an example of a lock right now in a little bit. The following thing is going to be this board up here. This is what we call your primary board, your master, whatever you guys want to call it. This one here, it's the one that's connected to the network, and you can see here it's got its network port right there. So that's where it gets plugged in, and it gets to talk to the your network. So once that one's connected to the network, that one is the one that communicates to the software, which in this case here we are using Genetech, and this one here communicates downstream to this other board, and that other board. What does that mean? It's an RS-45 communication downstream, and it just pretty much just gets wired from here to here to here to here, and they all communicate. In order for them to communicate properly, you need to set the boards on a address. So you set this board on these boards. How I have them on here, I got this on address 0, 1, and 2. And right here, here, and here, you can add more boards, right? If you had this enclosure here fully populated, you will be able to fit 8 boards, which each board takes 2 doors. So 2 times 8, 16 kit enclosure. So that downstream communication, it's pretty much going to be here, which you guys can try to clear this out. RS-45 communication, and then you get your RS-45 communication coming from the master board right here. You guys see that white, green, and black wire, white, green, black wire, white, green, black wire, and it's just making a big loop from here to here to here to here, and the communication just flows downstream and it comes back again. You guys could do a little bit more research on the RS-45 communication. I'm just going to go ahead and go through the basics here. I'm not going to get into very much details on every single thing. Showing you guys here real quick, this is where you land your card readers. So for example here, I don't know if you guys can see that, but I'll try to do my best. I believe, let's see, reader and reader. Okay, so reader 1 right here and reader 2. So that's where you land your readers on that primary board, and then on the following they have a different designation here, which you land your readers right here, reader 1 and 2, and then reader 1 and 2, and 1 and 2. So that's pretty much where you land your readers. Then you hook up your lock power. So usually for the locks, whenever we run a composite wire, which you can see the yellow banana cable right there, composite wire, and those white cables right there, don't ignore those. Those are other devices that we ended up having to add to the system, and we're not going to get to that. We're just talking about access controls. The banana wires, like I showed in one of my previous videos, and I'll just show you guys here how we usually like to keep our service loops up there. It's a high ceiling area, so that's why they're all the way up there. You obviously, on the banana wire, you have on your banana composite wire or component wire, that one has 4 additional cables, conductors in there, where one is for the reader, the other one's for the lock, the other one's for your door contact sensor, which is your sensor that will tell you when the door is open or closed, and I will show you guys that real quick. Alright guys, so here we have one of the doors that has access controls on it. This one has your motion request to exit device for whenever you're about to exit. It sees you and you are able to walk out the door without tripping the alarm system. There's no sirens involved or anything like that. You can add all that stuff, but not for this particular doors that we did here. So there's no need for you to worry about exiting and then not seeing you and hearing a loud siren. That is not applicable in this installation, but it could be added. So I will just demonstrate real quick what we got going on with this door, so you guys can somewhat understand the whole wiring concept that got going on over there in that enclosure. So you got your motion request to exit, and then on this one you have a regular handset, and here we installed the electric strike, and I will show you guys real quick. You grab your badge, and then you open your door. And that's pretty much it. It's your lock right there. Oh, also forgot to mention the little sensor is up here. It's the little recessed door contact, and it has a magnet in the internal part right here where it will sense when the door is open or closed. And that's pretty much it. Also, I would like to show you guys usually where that sensor is hooked up at. These boards have inputs, so I usually like to add the door sensor. For example, first card reader here, the half of the inputs, which this one has 8 inputs, I like to divide it in 4. The first 4 inputs will belong to the first card reader. The other 4 inputs will belong to the second card reader. So half and half inputs. Same thing will go for the outputs. For example, here I got 6 outputs. Half of the outputs for the first reader, and the second half of the outputs for the other reader. So that being said, this wire here is pretty much my door contact sensor right here, and then this following wire under it is my request to exit, which in this scenario here, it's my motion detector right here, which is sending a signal for the system to be able to get a clear exit and not have the system go off on alarm, or depending on what type of notification they want to go ahead and trigger. Also, that being said, this here right here, this is to hook up your power. Do not like how that is, but I have to fix that. So power, I usually like to get my power from the first power supply, which is this here. Let's talk about power a little bit. This enclosure here has 2 power supplies, and they could either be 24 volts or 12 volts. The blue light indicates that this power supply is 24 volts. And then there is a little toggle switch up there. I don't know if you guys can see that right there. And this one's turned down to 24 volts. And then my other board, well, my other power supply is turned on to 12 volts. And this one has the green light. So this one is pushing 12 volts and this one is pushing 24 volts. I like to keep all my lock sets, my electronic locks, in at 24 volts, and anything that has to do with 12 volts will use this power supply. That explains the fall-on lights on these M8 boards right here. I believe they are M8s. I keep forgetting the name of it. This is M8, yes, and these are your C8s. So anyways, this one here is the one that controls pretty much your power under a relay. The blue lights, like I said, and this is a pretty smart system. It has some type of smart LED system that will tell you if it's on 24 volts or 12 volts. So these blues indicating, like I said, blue, getting power fed to it, 24 volts, and green, which is 12, green right here. And don't get these lights here confused. That's just indicating that the AC is turned on. We're getting high voltage to these power supplies through this little box in here. This is where you come in and you hook up 120 and you turn it off and on, and then that feeds down to these boards. There is a lot of information, good information, in lifesafetypowersupply.com that could be very useful. Usually these enclosures come with the manual here on how to hook everything up, just the basics, you know. But that being said, so pretty much here is where my other set of wires come in from the composite for the lock power. This is the black and red. We like to use black and red, and the white and green on that 18-4 wire, we like to keep it as a spare wire. And here is where my power comes from the field and goes here. Up here are my inputs. So, and hopefully I'm explaining myself decently well. So this here is my output right here. For example, let's go ahead and do this real quick. So this is 1, 2, 3, 4, fourth door. So this is the first on the board, so this will be door number 3. So this wire right here ends up going on 1, 2, 3, the third spot. So whenever this circuit right here gets closed, because it's normally open right now, this gets closed, sends a signal through that wire and goes here on the third one and sends a signal out through here. The little light changes state, goes through the fuse and second relay, and then this relay is normally open as well. It closes this one as well. When it closes, it sends power downstream to the lock, and that's what makes the door open. So if I were to grab my pair of scissors here and I were to short out this right here, you guys will see a light change over there. So I'm gonna short it out and I'll show you guys what I'm talking about. Let's see if I can get to that. It's kind of hard to get to it, but yeah, I'm not gonna be able to get to that one right there. Let's see if we can reach this one. Okay, so I'm shorting this one out right here real quick, and as you guys can see, I'm shorting that one out. When I do that, I'm sending power to a lock out in the field. The reason why we like to use these boards is because there is a protected fuse right here, those little purple ones. In case there's a short in the field, it will go back to this board and then it will blow this fuse off instead of blowing these relays here, which go to the terminal block right here and then trashing out one of these boards. You could always use another output, right, in case that relay burns, but since all these are soldered back together, I really don't know if we really want to take a risk of burning a $300 to $700 board, depending on whatever it is and what capability it has. So I'd rather blow a couple cents fuse here instead of burning one of those boards. That's why we have this protected relay here to actuate our power out in the field. And then down here is where we usually land our motion detector, which is our request to exit. So it could which is, this is the other wire up here that I was talking about, white and green, and then we got the black and red over here. And that conductor is our request to exit, which is pretty much that device up there, and it triggers so you can have a clean exit without having the system to go off an alarm. That device requires power, so that's what this is doing here. This is feeding power to it through that black and red wire, and then the sensor input, it's right here. So it's just pretty much 4 wires in that conductor that's going to that device, and then we hook it all up, black and red for power and white and green for the normally open input, or closed depending on whatever you want to use it for. So the following thing is our batteries here. I got 2 batteries here hooked up together to power for backup power for this power supply, and then I have 1 battery, 12 volts, for this power supply right here. And that's pretty much it. Just quick video basics. I forgot to mention also, this is a smarter system right here where you can control and modify all your relay states, and change like these relays right here from normally open, normally close, and then there is infinity things you could do with this. This is pretty much like your brain with all the nerves, you know, telling through these little white wires. These white wires, jumpers, are all the nerves going back to the brain, and this one is monitoring everything that has to do with the power supply side. If, for example, I unhook one of these batteries right here real quick, there will be a amber light pop up somewhere in here in a few minutes. Well, in a few seconds, hopefully. Take this other wire off. And one more. Okay, there you go. So you guys see that light right there? That's what I was looking for. System fault, meaning that the batteries are low or batteries are not hooked up properly. So anything that has to do with a failure on the power supply side, either you get a light here and you would get a notification through the internet through this device right here. And you can even remotely change state change on some of these relays right here. You don't have to come out to the field and inspect it. You could go through there, access it remotely, and have the service technician know in advance what's wrong or what could potentially be what's happening out there with the information that we get from the customer on a service ticket. This will conclude the video of today, and hopefully you guys have a great rest of y'all's day. And please remember to like and subscribe, and if you guys have any questions, just feel free to leave them down below in the comments, and I'll try to get back with y'all as soon as I can. I apologize, like I said, for not uploading videos. I've just been super busy. But yeah, guys, you guys have a good one. Peace.